Hi everybody, welcome to the What's New session for the ArcGIS API for JavaScript. I'm Julie Powell and I'm a product manager for the JavaScript API, and I'm joined with Lloyd Heberly and Javier Gutierrez, who are both product engineers for the API. Okay, let's get started. So first of all, I just want to remind you that a great way to get to know a new release is by going to the samples page and just search for the version number. And it'll pull up all the samples we've created for that particular release, showcasing the different new capabilities. But we also add samples that are not necessarily tied to new capabilities. It's just a new sample showing something useful. So it's a great way to kind of check out that new functionality. All right, so I'm going to talk about performance, modernization, visualization, and quite a bit more. Now, I always like to start with performance because I really do feel like it really affects the overall experience in your application. And really, a lot of work has taken place on vector tile layers to improve the load performance and also enable a smoother interaction within your apps. So for example, we're now generating 20 to 25% fewer WebGL calls and then also a lot less JavaScript calls. That's really contributed to the overall improvement with vector tiles. We're also doing smarter caching, which has reduced the amount of network requests, and then added progressive drawing and symbol blending. And finally, we've optimized the drawing pipeline by requesting all needed tiles earlier so they could be processed and then drawn sooner. Okay, in terms of feature layers, there has been quite a bit of improvement here as well. You can see on the left-hand side, version 4.11, and then all the improvements we've done since then. This map is loading more than 30,000 zip code polygons. And this is due to a variety of things. Part of it's due to optimizations related to processing of geometry without losing quality. And then we've also improved the GPU performance by reducing the number of vertices that we're drawing. In terms of lines, we're really improving the line processing by minimizing the JavaScript function calls that are needed. And then also when there's thin lines, we've moved to a real simplified processing technique, which results in a lot less vertices without really seeing any difference in the actual drawing of the line. And then, of course, as you've seen in Jeremy's plenary part talking about feature layers and feature tiles, so much performance is gained using feature tiles and the smart way of requesting tiles and processing them, and then also taking advantage of the feature tile cache. So definitely check out Plenary if you want to learn more about how that all works. For fast rendering, we've done some really interesting things, which basically keeps the geometries on the GPU so that you can, as you update any render, so you can change actual style of the map you're drawing, or you can change the actual attribute that's driving the visualization. Any of that could be updated, and since the geometries are remained intact on the GPU, we're able to do these really fast map updates without any sort of flickering. And you can actually kind of play around with this capability if you use the new map viewer. When you're kind of picking different styles for a layer, you can see that changing it is just, changing the style really is updated very, very, very quickly. And it's all due to the underlying API, which is being really smart with how the geometries are managed on the GPU. Okay, switching gears just a little bit. Another place that we've been focusing on is modernization. And we do that to really improve the developer experience and the end user experience. The API leverages the power of modern browsers to enable a rich experience. And you've seen that, throughout the plenary and the various demos we've done. And that's, due to a variety of things. For example, full WebGL rendering. All layer types are rendered WebGL at this point. We use WebAssembly for the client-side projection. And we investigate, other components within the API. Does it make sense to use WebAssembly? We're kind of testing it out to see where we would get an important gain in performance. And we also take advantage of web workers in a variety of places, but one example is the client-side querying. Another way that we modernize the API is whenever possible and as soon as it's available, we take advantage of out-of-box capabilities that are part of the browser. So we don't need to ship additional JavaScript code to be able to format dates or numbers appropriately for internationalization. We could just now use what's available in the browser. And this is just one example. And now I'm going to talk a little bit about what's kind of in progress. We're rolling it out bit by bit, but it's still, we have more work to do here. And we're really working to modernize how the API is consumed so you can seamlessly integrate it with frameworks and any kind of developer tooling. And with this seamless integration, you can integrate the API in an app by installing an npm package, use any build tool you like, and then it just works without any additional plugins. So in order to achieve this, we really need to deliver JavaScript modules, and it would just be an additional option alongside the current AMD modules. So you could do either approach. And so in terms of how far we've gotten, there's a few things we need to do. Most importantly, we need to remove Dojo. So because browsers have what we need, which didn't have it originally when we first released the API, now we don't actually need Dojo for the things we're using it for. So for example, using WebGL for graphics rendering. Now we're working on native promises. That's already actually going to be on by default in version 4.15. You can actually do an opt-out option if you'd like, but then eventually that'll just be the approach going forward is the native promises. And then internationalization, as I'd mentioned. So if you want to take a closer look at this picture here, this is comparing the API classes that have dependency on a Dojo plugin in version 4.11 versus 4.15. So you can see there is quite a bit of difference. If you see that little flower looking thing, that is all the widgets dependency on localization. So that's one of the biggest pieces we have left to replace. And then we've also completed our migration to TypeScript, and that is of version 4.15. So that's pretty exciting. So here, just kind of looking at the native promises, and as I mentioned, you can opt out of it in version 4.15. It'll be on by default, but you can opt out. And then version 4.16, we plan to remove it and only have native promises. So what's left to do is continuing to remove Dojo. These are the kind of two pieces we have left, but there's some other things there. And then also, we need to create a new build system, and it'll make it easier to integrate custom builds using the modern build tooling. So those are two things that you'll be seeing us work on throughout the year. So this is what it'll look like. Once we're done with all this work, this is what your code can look like. So if you look at the import statements there, that it's as simple as that for using the ES modules. Okay, let's talk a little bit about visualization and specifically vector symbology. I'm just going to run through a few examples to really highlight some of the strengths of this new capability. So first of all, the API now comes with 100 different vector symbols that you can use just by referencing them by name. So this very simple sample is showing points of interest in Los Angeles. As you can see, I zoom in and zoom out. They really, scale beautifully because they are vector. If you want to see all the different symbols available, go to Guide and Reference, and then here you see Esri Web Style Symbols 2D. So these are all the symbols we currently have available, and you just figure out which one you want, click on it, and then you can see how you reference it from your application. So these symbols are actually like any other symbol in the API, and that means that you can do things like this, use visual variables to size them any way you want, and again, these are vectors, so they'll always be looking really, really great on any screen at any zoom level. So these web style symbols are actually, under the hood, they're based on something we call SIM. So SIM is the platform's cartographic information model. It's used in Pro and used in runtime. And basically, you can define very, very sophisticated symbols using this. So if you don't want to just use a very, very simple web style symbol like this, and you want to actually have something a little bit more dynamic with your symbology, you can actually go in and define any sim symbol you'd like. So this particular example, it's called Worman's dots if you want to look for it in the samples. What this is showing in this particular example is the percentage of land covered by forest, also mixed in with population. So the dots that are more green, that have more of the circle filled in, that's a very, very forested area with little population. So having a look at how that's done, the important part to point out is here. Basically, first it's calculating the size of what the outer circle could be. That's not data driven, is driven by scale. So you can see it's changing. And then the inner circle is created based on the forest ratio. So it's a really interesting example to have a look at if you're interested in doing something a little bit more sophisticated with the vector symbols. Also related to vector symbology is something we're calling the dictionary render. So the dictionary render is something that I think is very, very exciting because it really gives you the flexibility to dynamically create these symbols. In this particular case, we're looking at alternative fuel stations. And you might think that, oh, it just looks like something you'd use with a unique value render based on the fuel type. But then as you zoom in, you see that these symbols turn into something, quite a bit more sophisticated. You got the station name, the network type, the outlet type, the fuel type, and really you can define anything you want, any sort of dynamic behavior that you'd like for creating your symbols based on an expression. So if you want to learn more about how these dictionary renders are put together, here you have below in the sample how to create the dictionary symbols service. So this takes you to GitHub and explains how these dictionary styles are put together. Eventually, it'll be a lot easier to create these dictionary styles once you can publish them and then just simply consume them in your application. I wanted to show you one more example of dictionary render because I think it really shows, what that power can be. It actually looks very, very simple in the application, but under the hood, it's using this dictionary render. So if I click on one of these guys, these are like call incidents that I've mocked up. Opens a pop-up. This is a custom action opening the editing workflow. And if I change the status from new to, say, completed for this particular call incident and update it, it changes the color of the outline. I can then go back and say, well, okay, this is a something that's in progress, and then update it, and now you see it's brown. It's also the inside of the symbol represents the type of the incident is, and then here you have the phone number. So this entire symbol is pieced together based on the status of the incident. So this can become very, very useful as you need to create, if you've got a very, very, very large library of different symbols you're using based on different conditions, now you can just use logic and apply the different symbol parts that you need to create that composite symbol. So here you can see the code. Actually, your JavaScript code remains very, very simple. All you really need to do is point to that dictionary render style definition that I had mentioned with GitHub, and then create a map between the variables in your dictionary style that you defined and then map that to the attributes in your feature layer. And that's really it. It's very, very clean, simple code within the JavaScript side, on the JavaScript side. Okay, next thing. So many of you have been waiting for clustering in the 4X API, and now it's available. You can use it in feature layer, CSV layer, and GeoJSON layer. And you have a couple different ways in which it can work. First of all, if you just want to show the quantity of features under a particular location, you can just use the simple render. If your layer underneath the clustering is using visual variables, what they do is basically take the average value of the underlying data of that area and then uses that to generate the symbol. And then finally, if your layer that the clustering is working on is using a unique value render, essentially the predominant value of that underlying data is used for the clustering symbol. And then what's cool is when you click on a pop-up, actually that pop-up represents the cluster. So as soon as clustering is turned on, you can see that now it shows how much is represented by that particular symbol, and what the values are. And again, that's all based on the type of render you've set up for your layer. Now, if you're visualizing temporal data, one thing you might want to be able to do is allow your end users to interactively explore it based on a time extent. So what we've done in the last year is introduce time-aware layers in the API, and then also the views that know how to display it. And then the time slider widget, which is the interactive part, which allows your users to go ahead and explore the data based on a time extent. So what's happening under the hood is the different layer types have something called a time info. So time info has things like date fields, which says perhaps like a feature when it should start and end, and then also information like the total time span for the layer. Then the view has a time extent property, and if that's set, then it basically displays whatever data that falls within that time extent. So then when you move the time slider widget, it's actually changing that time extent property in the view and updates what's displayed on the map. In this simple example, we're looking at sea temperature based on date. So if we have a look at the code, basically we're just creating that time slider. And since we pass a reference to the view, that's what actually gives it the ability to change the view's time extent as these little handles are moved. You can play it or you can manually just move it and see the change in the data. The other thing that's happening here is it's getting the time slider's extent from the layer. So here, as I mentioned before, the layer has time info. It gets the full time span from that layer, and then that's how it figures out how to set up the time slider. And then also it figures out the appropriate stops based on the interval in the time info. It's important to notice that it does have to wait for that layer to be created. So that you can actually get that information out of the layer. That actually could be a pretty good gotcha right there if you don't wait for that. I want to show another example, and this one's interesting because it's doing something a little bit different. In this case, I built this demo for the European Developer Summit in Berlin last year. And what it's doing is showing tree expansion in Berlin over time. So each of these features shows a tree that was planted, and then it's all based on the year that it was planted. As I move this little handle, you can see how it changes over time. So what's different about this example is rather than passing a reference to the time slider to let it control the view, I'm actually just using the time slider's time extent and setting up a filter on the layer. And the reason why I'm doing it manually is because I decided that I want to still show all the trees on the map that happened up until this, this time period, the second handle, and just apply a filter effect on the ones that are not within this time extent. So basically everything that's kind of more grayed out, has some opacity, those are trees that were planted before the time period of focus. So you can kind of highlight what happened during that time period, but still show everything on the map that happened before then. And I think the power of that really just shows the cumulative growth over time of the trees, rather than just what happened within that time extent. So you can use the time slider that way too. So basically just get whatever, the current time extent is as the user moves the map. And then here I'm setting an effect on the layer view, specifying the grayscale and opacity for all the trees that happened before that time frame. And the filter effect is something we introduced back in 4.11. So this is just taking that same filter effect and applying it into a time perspective. Now this is something that's also fairly new. It's introducing something that we're calling time offsets. So if you have a look at the map, these are like the wildfire seasons, and it's combining multiple years. Sorry about that. Combining multiple years of fire on the same map using the same time slider. So you wouldn't want 4 different time sliders to control these layers. Essentially, you could put a temporary offset, say 1 year, to various layers so that you can put them on top of each other and all be directed using the time slider. And that's really powerful. So if you want to compare things like how something changes between years, you can display them all on the map at the same time. So that's the time offset. And now I'd like to hand it off to Javier Gutierrez, and he's going to talk about some 3D enhancements.
So let's have a look at some of the new features of the 3D JavaScript API. Most importantly, we're very happy to introduce feature layer editing in 3D. This means that you can now edit your point, line, and polygon geometries directly in the scene, including their Z values. Let me show you what this means using this demo app that allows me to plan a drone flight in 3D. The scene is showing the university campus in Zurich. I previously added a feature layer with lines where editing is enabled. I also added the editor widget that is now fully supported in 3D. This means that I can now go ahead and start creating a new line on the ground. Using the new set-to-where editing tools, I can lift that line up in the air. Laser lines projected onto the surrounding objects help me place the line and each of the vertices at the desired height and location. I now have a clear idea where my drone will fly through. Using the editor widget, I can also change the attributes. For example, let me give my new drone flight a name. When I tell the editor widget to persist a 3D line in the feature layer, my drone app will automatically create point symbols representing photo stops where the drone will take a picture during its flight. These point symbols are visualized using 3D objects and are stored in another point feature layer. Again, I can use the set-to-where editing tools to move and rotate each of the photo stops. This allows me to provide a preview of the pictures taken by the drone by hooking up the geometry and attributes of the 3D point symbols to a second scene view. Please note that this demo is not related to SideScan or Esri's efforts to provide an ArcGIS drone collection platform. This is just an example of how you can use the new 3D editing tools. We're very curious to see how you will use them for your own professional use cases. In the December release, we added 2 new interactive widgets to the 3D JavaScript API. One of them is the line of sight widget. It allows us to analyze the visual impact of 3D objects in our scene. For example, here using the Central Library in Christchurch, New Zealand. By placing an observer on this hotel and multiple targets on the opposite church, I see that the building obstructs some of the views from the hotel, while others are still visible. The other widget is the daylight tool, allowing you to control the time and therefore the sunlight and shadows in your scene. You can analyze the shadows for different times and also different seasons throughout the year. Play buttons make the widget animate the sunlight throughout the day. Now, if you are like me and used to the shadows moving in a different direction, well, that's because we are in fact looking at a place that is on the southern hemisphere. Another addition to the 3D JavaScript API is the possibility to align point, line, and polygon features directly onto the integrated mesh. This means you can either drape graphics on an integrated mesh, but also place 3D objects on top of it as if it was the ground. Whether your integrated mesh shows terrain or urban areas, this is a great way to convey additional information with your 3D imagery. We constantly improve the performance and visual quality of the 3D JavaScript API. One example is the support for the latest i3s specification, version 1.7. i3s is Esri's open standard for streaming large amounts of 3D data, such as 3D objects, point clouds, integrated meshes, or BIM models in building scene layers. The video compares the loading times for different viewpoints on an integrated mesh. With supporting the latest version of the i3s specification, the API now loads scene layers up to 4 times faster. The i3s standard is available in Esri's GitHub repository. To make sure you benefit from these performance improvements, make sure you update your existing scene layers to the latest version of the i3s specification. A converter tool that helps you do that for your existing scene layer packages is available in the public GitHub repository. As already mentioned, besides performance, we also improved the visual quality of the JavaScript API. One example is the addition of a new animated polygon symbol for visualizing water. By adding it to our scene, we can see the animated waves and reflections on the water surface. By tweaking different properties directly on the water symbol, we can change the wave strength and the color of the water. We also added a new lighting and shading model, making 3D content in your existing scenes have more contrast and definition. In addition, GLTF models now support PBR materials, improving the visual quality and adding reflections to glass or metallic surfaces. 3D vector and raster tiles, including base maps, elevation and imagery, now load and display a more homogeneous scale level. Streets, labels, and other draped content now shows the same level of detail in large parts of the view, even when tilted. Last but not least, various transparency improvements in 3D scene layers now correctly render opaque objects behind transparent ones. With this, back to you guys.
Hello, my name is Lloyd Heberly. I'm a product engineer on the JavaScript API team, and I'm going to be talking about some of the enhancements we've done with smart mapping, widgets, and then some various other updates. Over the past year, we've put a lot of effort into reworking many of the guide topics, and some of those include the data visualization walkthroughs and guides. Smart mapping now has feature parity with version 3x of the JavaScript API, so those of you that may have been waiting on some of these features can now move forward and have these visualization techniques at your fingertips. So whether you're used to doing some of this automatically with the help of the online map viewer in ArcGIS Online or on-premise in the portal, we're going to look at some of the programmatic techniques that are used in order to author these smart mapping. In the guide section under data visualization, you'll find a visualization overview. Now, depending on what type of data you're working with, if it's point lines or polygons, or if it's 2D or 3D, this guide topic will give you a good overview of either what you've been doing already in the online map viewer or some of the things that you'll be interested in working with in using the smart mapping APIs if it's using the creators or integrating those with the various sliders that help you build a nice data exploration application. So I would encourage you to check these topics out. So there's some different ones on doing this manually, like programmatically. We also have a best practices guide that covers the new guide topic for the choosing color ramps. So in addition to deciding how you want the features to look visually, you also need to have a good understanding of what kind of colors you pick. And this guide topic is essentially a graphical representation of what's available in the API programmatically. At version 4.12, we introduced smart mapping. This is where you can randomly draw dots within a polygon feature to understand density of some attribute value for that given location. You can find those samples in the SDK by searching dot density. Christian, who's a product engineer on our team, writes a lot of great blog articles about visualization techniques, and here is one on dot density that you might find useful. One of the other smart mapping techniques using adjusting size by scale was released in the December timeframe at version 4.14, and it allows you to dynamically change the size of points based upon a scale threshold. So if you're zoomed out to a world geographic extent, or if you're zoomed into the country geography, these sizes will vary and change based upon the view's scale. So it's kind of having best of both worlds. You can find these related samples by searching using the size keyword in the samples. So here, if we look at this example and turn these off, you can see the points are very cluttered and overlap, and enabling those features makes them smaller at this scale and makes those look a lot better. This is occurring by using the arcade's expression view scale, and then based upon what scale the map is at or the view is at, it corresponds to that scale and then decides to draw them at a particular size, which can be in points or pixels. Another smart mapping technique is rendering features or graduating the symbols by scale. So at a state level scale, say like we're seeing at the right here, you may have your lines widths thinner, and then when you zoom in at larger scales, those line widths increase in size. This feature was added in the December release at 4.14. And if we look at that sample code, you can see these various sizes change as we zoom out. And this is achieved by using that same view scale arcade expression, and then using a field value in the layer for the traffic density, and then setting up max size and min size and the various stops. And so at the different scales, we will control the width of that feature. So I wanted to just touch upon the difference between creators and renderers. These creator modules help you dynamically generate the values that you see that get used in the renderer. Now, this is great for data exploration type of applications, such as the ArcGIS Online Map Viewer, or maybe you're building one of your own. However, you do not want to dynamically generate these at runtime just because you can. What you should really do is use some code like we're seeing here and then capture the value and then use that in your renderer so that you don't pay a penalty for rendering those at runtime. So if we take a look at this example here, we have a breakpoint set, and whenever we enable or disable this, the breakpoint is fired. And if we see over here for this response and visual variables, we are interested in that value. And so if we just output that as JSON, you'll see these stops and the view value expression that we would use in our renderer. So this is the type of thing that you would do as a developer. Under our support tab in our SDK, you'll see various blogs posted by different product engineers on the team. And one of the ones that I wanted to point out is this how and why to adjust symbol size by scale and web maps, written by Christian, who's a product engineer on our team. And these topics that we've just discussed are covered in this blog article, which I think you'll find helpful. Also, if you just look up Christian by his tag author name, you'll see all the various blogs that he's written on visualization that will be very helpful for you. Let's move on to widgets. So we have re-architected the widget structure from 3x to 4x. There's the view and the view model architecture, which allows us to write our widgets a certain way, you to be able to easily have an alternate view of those, or as a developer, write custom views of these things. So you're already familiar with this if you've been developing widgets, but this is one of the great things that makes the API very powerful. One of the other things that we are evaluating is potentially using web components to build reusable UIs and share easily across different frameworks, but that's more to come. I briefly wanted to mention some information about sanitizing malicious code that could be put or pasted into widgets or pop-ups. At the December release of 4.14, we added in this ArcGIS HTML sanitizer to basically remove anything that wasn't in the ArcGIS supported HTML spec. And as a result of some of the feedback that we've gotten from the developers, at this next release 4.15, we've relaxed some of that information or some of those restrictions. Here's the link to the supported HTML in that spec, and this is the GitHub repository for that ArcGIS HTML sanitizer. So if you want to know more about those, check those resources out. Let's move on to some of the different widgets. The swipe widget was released in 4.13, which was around the October timeframe of last year. Some of its limitations are it doesn't work with group layer, it's not supported in scene view, and basically it allows you to be able to swipe back and forth between the leading and trailing layers and see a before and after picture of that information. Another widget that has been enhanced is the bookmark widget, originally introduced in 2018 at version 4.8. The bookmarks were read from the web map, and that's all you could do. And in October release 4.13 of last year, we enabled you to edit those locally, either create new ones or delete existing ones. Probably in the future, we will enable it to where you can save it back to the web map. But right now, it's read only. And then it's saved locally in the view. The feature table is coming out at version 4.15. It has fairly limited functionality right now. It's really for giving your users to be able to view the attribute data in another way. So if we select here in this example, if we select records in the feature table, then they're selected in the map. And if we look at the code for this, we just have the feature table, which we wire up with the layer, set the configuration fields, and then list when the layer view is ready. Then we listen to some events that fire on the table, and then do the add and remove of highlighted features. In the December release last year, we added the ability to save web maps. This works with ArcGIS Online and ArcGIS Enterprise. You can also save web maps using Pro, online, on-premise, and then programmatically as of December. So you'll see in the URL here, we're adding the item and then the JSON that is posted back to save that item. So basically, you can load a web map after the portal is loaded, and then call web map save to save those features. There is a sample that we have that showcases this functionality called web map save, and you'll be authenticated to your portal, and then you can save your web map, and then once that's saved back to your online or portal, you can inspect and view that web map or even edit it. In addition to the work that we've done on the visualization techniques, the writing that has come with that, we've also worked on upgrading the framework topics. So under the developer tooling in the guide, you'll see a frameworks page, and that is basically just an overview of if your framework uses the Webpack plugin or if you need to use the Esri loader. And then there's topics on each individual framework that are some of the most popular ones. Finally, I would just like to touch upon the fact that we've added a deprecated section in the release notes. So this is a way for us to be more transparent with you as the developer, letting you know when stuff is being deprecated and give you time to remove those features from your applications. So at this point, I'd like to turn it back over to Julie, and she's going to walk us through a few things that you may have missed over the various releases since last year's Dev Summit.
All right, I'm going to cover a few small but handy little things you might have missed throughout the last year. First is the base map layer list widget. Basically is very similar to the layer list widget, only it works with base maps. It allows you to turn on and off the visibility of the base map layers, and they're separated between the reference layers and the base layers. And then if you have editing enabled, you can actually reorder them by dragging them around and then even changing the title. So it's a nice little widget. Another even more subtle thing is the ability to return the query geometry. So if you've seen some of our samples in the past, we actually, if you wanted to, like, for instance, draw a buffer around the feature that you're querying, you'd actually have to do a separate operation to calculate that buffer if you want to display that graphic on the map. So what return query geometry does is, say you do like a distance around the geometry that you're querying, it actually can, if you set that to true, it will return that geometry, so then you can just draw it on the map, something like this. The other thing is color ramps. So all of the colors that Smart Mapping works with, you might have seen this earlier. You can use the SDK to have a look at the different tags and themes that we use throughout Smart Mapping, and then browse them and actually use them directly in your application. So you can even use them outside of Smart Mapping. We've added a bunch of slider widgets, and again, this is to support various workflows, often with Smart Mapping, but you can use these within your own application. So we've added a lot of sliders that we built from the ground up for doing different things, like looking at different classes with colors, to the time slider widget, to the range slider widget, and it actually does all that automatic calculation of the range within your data and lets you explore it. So have a look at the different slider widgets. And then finally, oh no, actually I have something after this. This one is also pretty easily missed, but essentially the ability to disable single finger pan or disable a scroll zoom. The single finger pan is really useful if you're on a touch device. And then the scroll zoom. So say you have your map embedded on a larger page, and like say in a blog, and as you're scrolling down the blog, you don't want the user to have to actually start zooming when they scroll on top of the map. What you can do is disable it and then have them click on it when they're ready to, or touch on it when they're ready to turn it back on, or have a button to turn it back on. So you can control that, which will be an improvement to the overall experience for embedded maps. The last thing I'd like to cover is our /next repo. Now, this is giving early access to the API all the way from the beginning of the release up until right before the production release. And what we're doing is updating the /next release every week, and then even more frequently as we get closer to the release, so that you can go ahead and try it out in your applications, test it against your apps, and check bugs, give us feedback on new capabilities, and we can potentially fix these bugs and address any feedback you have on new capabilities before the release, which could be really handy for both us and for you. So go to the Esri organization on GitHub, and you can find this. To use it in your application, you simply just reference it from the CDN. It's also in the CDN /next. So you really just need to update the version from whatever version you have to next. And then if you want to explore the changes we have each week, we're keeping the changelog up to date. So each week we look and see what's available to be tested or ready to be tested. And in some cases, we even put a CodePen example. So this is the new feature table. You can try it out in CodePen, and yeah, play around with it. We even have a list of the breaking changes and bug fixes and everything. So check it out. When you're ready to submit feedback, you go to issues, and then you create a new issue, whether it's an enhancement request or bug report, and then you can interact with the dev team. So it's a really great opportunity to get involved and really play a part in the release process. And with that, I'd like to close the session just by saying thank you for all of your hard work, and we can't wait to see what you build with all of the new capabilities we've brought in the last year.